For those watching online, I'm David. Okay, so this is Maths 1A. It's semester 2, 2016. We've had some fun times so far. And we're just about to do some things about formulating an optimisation problem but not solving it. To set your mind at ease, there are already revision seminars about solving optimisation problems, both with slack variables and with geometrical methods. So to set your mind at ease, they are already there. I was quite proud of my texture drawings on the previous one. Optimisation problem formulation. That's what we're doing. Now I went up to a student, thank you Ben, this morning, and said, can I have a look at your lecture notes to see what the textbook references are for optimisation in your lecture notes? And there are no textbook references for optimisation in your lecture notes. Which was great. And so what I did is I went to the Maths Learning Centre bookcase, which has the old textbooks that used to be used in this course. And I pulled out a book on linear algebra, and I did exactly this. Let's see. Optimisation problems, linear programming, 578. Oh, it's in the optional section. Oh, look, I had a bookmark in it. Doing so well today. Okay, and what it has is some examples which I'm going to try. Where's the zoom? Oh, it's on here. Okay, in your lecture notes, Adrian and the first year teaching team have put some, I think, quite useful advice about how to go about formulating optimisation problems. They say, read the whole problem, look for what the goal is, figure out what things you have to find the answer to as part of that goal, and then look for constraints upon them, which is not the worst plan. Almost always, if you have a worded question, you should read the whole thing. It's like one of those classic problems where they get you to read all the instructions and the last one is don't do anything. Wouldn't that be great? But it's not that. So it's similar to that. So I'm going to read the whole thing. A trucking firm ships containers of two companies A and B. Each container from company A weighs 40 pounds and is 2 cubic feet in volume. Great. Imperial measurements. Each container from company B weighs 50 pounds and is 3 cubic feet in volume. The trucking firm charges company A $2.20 for each container shipped and charges company B $3 for each container shipped. If one of the firm's trucks cannot carry more than 37,000 pounds and cannot hold more than 2,000 cubic feet, how many containers from companies A and B should a truck carry to maximise the shipping charges? Beautiful. All right. Am I going to destroy my own book? Yeah, I will do it in pencil. Okay. So what we need to find is the thing that we need to find. It says how many containers from companies A and B, etc. The goal for this is to figure out the number of containers from company A and the number of containers from company B that I need. Those are my variables. So traditionally when you do a maths problem, the end it will say, you know, x is equal to, and that will be the answer for what you're looking for. Same goal here, except there's more than one x. Okay, I'm going to have two x's because I've got two different numbers I'm looking for. So when I'm looking for this, I'm looking for the thing I need to find and how many of them there are, and that's what I'm going to start with. So I'm just going to leave a space here so that I can cut and paste this in when I do the handout. Okay? Okay. Let XA be the number of containers from company A that are carried. All right. Now, if you were just doing this yourself for your own pleasure, you might not be that precise about it. But in an exam where someone's reading it, you need to be very precise about exactly what the variables are. Like, don't just say, let XA be company A, because XA is not company A, it's a number. And I don't just say, let XA be the number from company A, I say it's the number of containers from company A. Be extremely precise about what number that is. And that's not just because you want to please the people who are marking it, it's also because you want to know for yourself that XA really is a number and what number it is. And XB be the number from company B. It's okay to be less precise for the second one because that's just good writing. You know. Okay. The next stage of this is to try and organise the information that we have. Now that is not in the instructions that you have from your lecturer, but it's a very useful piece of advice. Organise the information you have in a format that will make it easy to see what the constraints are when we get there. I find a table is quite useful. Now let's just look at this. The thing that distinguishes between XA and XB is which company they belong to. So what I'm going to do is I'm going to make a table that has company A in one column and company B in the second column. It may go over the page. I'm going to put some things here. All right. So we do have one thing that we've already written down. So the number of these. The number of containers, and it's XA and XB. That's what we have so far. The next one says each container from company A weighs 40 pounds. Weight of each container, 40 pounds. And in company B, oh, just a second, we have a volume as well. Volume of each container is 2 cubic feet. Okay. Each container from company B weighs 50 pounds. You have to trust that I'm putting it on the thing. And is 3 cubic feet in volume. Okay, so what I've done is I've added my information to the table, like that. Beautiful. Next sentence. The trucking firm charges company A $2.20 for each container. Charge for each container. It's $2.20. And $3 for each container from company B. Okay. If one of the firm's trucks cannot carry more than... Okay, so this sentence doesn't contain any information about company A and company B. So it can't be part of this table yet. I'll have to deal with that later. But let's just see what it says. Okay, so it says that the trucks carry a total number of pounds. Okay, so somehow I'm going to need to figure out a total number of pounds, because that's what that number is about. That number is about the total number of pounds, so I'm going to need to do that. Now, that's information about both company A and company B together. So in some sense, there needs to be like a total column. We'll get to that in a minute. So I'm just going to continue my table. It's good writing to put the headings at the top of the next table when you switch pages. Okay, so we're going to need like the total weight. Okay, so the total weight from company A, well, let's see. I can zoom out now. I don't think we're going to need to. I'll zoom out a little bit. So company A has XA containers and each of them's 40. So the total from company A is 40 lots of XA. XA lots of 40. That's the same thing. Company B has XB containers and each of them is 50. So the total is 50 times XB. And here's the trick. These two numbers together is the total weight. Right? And that total weight, just a second, I can't carry more than that, so it has to be less than or equal to 37,000. There's one of my constraints. It's an abuse of the way that I've done this table that I put the plus sign in the middle, but I think it'll be okay. And then it says they can't hold more than that many cubic feet, so I need a total volume. So from company A, the total volume is, we've got this many, and each of them's got 2. Company B, we've got this many, and each of them's got 3. And the total volume, so that's just the total, has to be less than or equal to, what was it? 2,000. Okay, doing well. How many containers from companies A and B? We've already done that bit. Should a truck carry to maximise the shipping charges? Okay. Total charges. So we've got XA containers and $2.20 from there, and XB containers and $3 from there, and that's the total charges. Which you don't, like, this is the objective, right? And I think that's all the information we need. We've gotten to the end of the problem and we've written everything down there in our table. It's all here. Some of these things, we didn't use raw. We had to combine them together to make these things. That's all right. So the final step of this is to actually write down the answer in a particular, well, the question in a particular format. Because if you put it in a particular format, the person marking it will find the bits they need more easily. So you will say a sentence like this. Maximise the total charges, which is equal to... You don't need to say total charges. This is now a maths problem. It can just be letters. So maximise C, which is equal to that. That's my objective. Subject to, and we have some equations. We had 40xa plus 50xb is less than or equal to 37,000, and 2xa plus 3xb is less than or equal to 2,000. And technically, we can't have negative containers. Not today. So this is what it would look like when you formulate something as a linear program. It will always be maximize or minimize some function subject to some things. And that's what you need to write. And that is done. I mean, the rest of the problem is solving it, but it's very common in exams to just have formulate it but do not solve. Cool. Do you want me to do another one? We've got yeses and nos. I'm going to go yes, because then future generations will have more to look at when they get to this. Now I will continue, just so you know, if you have other questions, a little bit longer than I planned. If you don't have the stamina, feel free, but I will record it. Anyway. Let's do the next one. Has everyone got this? Repeat exercise 7, that's not going to be a problem. That's not about the formulating. All right, I'm going to do number 9 here. A manufacturer produces sacks of chicken feed. They're always so interesting. From two ingredients, A and B. My chickens love A. Right. Each sack is to contain at least 10 ounces of nutrient N1, at least 8 ounces of nutrient N2, and at least 12 ounces of nutrient N3. Each pound of ingredient A contains 2 ounces of blah, blah, and blah. Each pound of ingredient B, blah, blah, blah. Each ingredient of A costs 8 cents per pound and ingredient B... Sorry, if ingredient A costs 8 cents per pound and ingredient B is 9 cents per pound, how much of each ingredient should the manufacturer use in each sack of feed to minimise his costs? Okay, just a second. How much of each ingredient? Okay. All right. Well, those are the things we need to solve. So let be the... What are they measured in? Not sure the units yet, I'll put that in a second. Ingredient A in a sack, and XB, the number of ingredient B. Okay, not sure what they're measured in yet. I'll get that in a minute. So we've got sacks. We've got each pound of ingredient A here, each pound of ingredient B. Ingredient A costs 8 cents per pound, ingredient B 9 cents per pound. Okay, so the units should be in pounds, because everything talks about these ingredients in terms of pounds, so my units will be in pounds. Okay. Damn it, I didn't leave space for the question. Oh, there's space at the bottom of the previous one. Okay. Okay, so looks like the ingredients are what's going to distinguish between things. So we have the number of pounds in our sack, and this was XA and XB. We don't need a total. Well, I guess I'll just... Okay. Actually, we do need a total. Not sure. We'll figure that out in a minute. We might need a total. Right, let's start from the beginning. Each sack contains 10 ounces of nutrient N1. And we don't have the nutrient N1 listed here yet. Okay, so if I'm going to figure out how much of nutrient N1 there is in total, I'm going to need to know how much there is in each pound of ingredient A. So I need to find that information. Here we go. Each pound of ingredient A contains 2... Okay. So... number of ounces of N1 per pound, and we've got number of ounces of N2 per pound, number of ounces of N3 per pound. Okay, so let's see. Each pound of ingredient A contains 2 ounces of N1, 2 ounces of N2, and 6 of N3. Each pound of ingredient B contains 5 of N1, 3 of N2, and 4 of N3. So that's that bit there. Okay. Let's just go back here. Each sack contains at least 10 ounces of nutrients N1. So that's sort of the total N1. So let's see. There's XA sacks, and each of them has 2 ounces. So that's how many N1 there is from the ingredient A. There's XB pounds and 5 per pound. So that's the total amount. And it needs to be at least 10 ounces. So the total has to be greater than or equal to 10. Total N2, 8 ounces. So we've got 2XA and 3XB here. Total N3. 12, which is 6XA and 4XB. Doing well. So what have we dealt with? We dealt with this, dealt with that, dealt with that. Sorry. We've dealt with that, dealt with that, dealt with all of that. Now we've got the cost. Cost per pound. Okay, so ingredient A is 8 cents per pound. Ingredient B is 9 cents per pound. And what did we want? Minimize total costs. So we're going to need total costs. So 8XA and 9XB. And that's the objective. All right. So now I can pull everything out of the table. So what did we want to minimize that, didn't we? Minimize this function. Subject to 2XA plus 5XB is greater than or equal to 10. 2xa plus 3xb is greater than or equal to 8. 6xa plus 4xb is greater than or equal to 12. And I suppose xa and xb have to be greater than or equal to 0. That's it. Some of them are way more complex than that and involve combining things together in multiple different ways. My instinct is that if there is one in the exam, it will be of that level. This level, the level that we've just done.
Do you reckon we'd have to solve this as well?
You don't normally have to both formulate and solve at the same time because there's only 2 hours and you've got all this other stuff to do. I cannot guarantee anything. There have been exams where it has actually done the slack variable thing and they've just asked you to do a couple of the slack variable row operations, like 2 or 3 of them, and not had this. There are ones that have done this and then maybe asked you to sketch the region, but that's the extent of what they want you to do and they don't want you to solve it. With these 2-hour exams, they sort of try and do at least, if they ask you to do it, they'll do at least part of it for you. So you're going to have to be a bit cluey in noticing if they've done part of it for you, rather than launching into the whole thing. All right. Anyone got any thoughts or questions about that before I move on to something else?